Good morning to one and all. So, I am Dr.R.Radha, Assistant Professor of Chemistry Department, SFR College. Today we have seen about the structural elucidation of menthol. First, you know about the structure of menthol. This is the structure of menthol. It is a major component of peppermint oil which is obtained from the fresh flowering plant of the Mentha pepperetica. It is a monoterpenoid compound because it contains two isoprene units. It is joined to head to tail to isopropyl units. So, it is a colorless crystalline compound and it has a room temperature at melting slightly above 35 degree centigrade. So, constitution of menthol. First of all, we know about the menthol. The molecular formula was determined by the elemental analysis and molecular weight determination. From that, we have identified the molecular formula of the menthol is C10H20O. It is a saturated compound. On heating with the selenium, it gives paracymene. So, paracymene is a saturated compound, and the formation of paracymene suggests the menthol has paracymene skeleton. So, menthol under reduction with hydrogen iodide gives paramenthane. This confirms the structure of menthol has paramenthane skeleton. So, this is all evidence for the reduction of the menthol gives paracymene. Further, it was reaction with hydrogen iodide gives paramenthane. Then we have to prove the nature of oxygen. Already we know that the side chain in the structure, we have the hydroxyl position as the secondary hydroxyl. So, menthol on oscillation with acetic anhydride and pyridine at room temperature forms a monoacetate. Formation of monoacetate shows the oxygen is present. It forms a hydroxyl group. Then we have acetylation after room temperature show that the hydroxyl position of menthol is either primary or secondary, but sure not the tertiary in nature. So, menthol on oxidation with chromic acid forms a carbonyl compound which identify as a ketone. So, from that we have to identify the nature of oxygen is secondary. Then the position of hydroxyl group. So, menthol on oxidation with chromic acid gives menthone. It is on oxidation with potassium permanganate gives a keto acid. That keto acid is identified as 6-keto-3,7-dimethyl octanoic acid, commonly known as ketomethylenic acid. And further it was oxidized with KMnO4 to give 3-methyl hexane diionic acid and acetone. So, from that we have to identify the hydroxyl position, the OH position at the ring side chain of the menthol. So, this is the reaction evidence. The menthol was oxidized using chromic trioxide or chromium oxide in presence of acetic acid gives menthone. The secondary OH group was oxidized into keto group menthone. Further, it was oxidized in presence of KMnO4, it gives a ketomethylenic acid, and it was further oxidized gives acetone and a keto acid. And this is what the synthesis of menthol. So, synthesis was starting material is metacresol. So, metacresol is hydrogenated, this reduction was occurred, the total double bond unsaturation was converted into a saturated compound. Further, it compound was oxidized in presence of CrO3, chromium trioxide gives 3-methyl cyclohexanone. So, further it was a reaction with diketoester, it gives the beta keto ester. That means the substituent beta keto ester was a substituent at in the second position of the double bond O. So, then it was a reaction with the calcium acid, it gives a dicarboxylic acid. It looks like a dicarboxylic acid of phthalic acid. So, then it was react with the calcium anhydride gives menthone. Further, it was heated with copper chromite, it gives pleasure menthol obtained. So, it was resonated with KMnO4 compound. The stereochemistry of menthol. So, menthol we see that the structure of the compound, we have seen the 3 chiral carbons are present in the structure of menthol. Say this the substituent at isopropyl and then the substituent at the hydroxyl position and methyl. These 3 groups are the chiral center. So, it forms, already we know the formula of chiral center is 2 power n. So, 2 power 3, n is equal to 3. So, 2 power 3, 8 compounds are possible. That means the 4 enantiomeric pairs was obtained. These are the enantiomeric excess compounds, plus or minus menthol, plus or minus neomenthol, plus or minus isomenthol, and plus or minus neoisomenthol. So these are the structures of plus or minus menthol, plus or minus neomenthol, plus or minus isomenthol, and plus or minus neoisomenthol was shown in the slide. So thank you for visiting. Thank you.